Alright, so this one's on arithmetic sequences, and what we're going to have is we're going to be using this basic formula for arithmetic sequences. Okay, and arithmetic sequences are ones that have a common difference. So first, what do all these mean? Okay, this formula here. So let's start with the first term. A is going to represent the first term in the sequence. D is going to represent common difference. The common difference of a sequence can be positive. It can be going up by +2, or it can be negative. It can be going down by 7. Okay. Next up, this guy over here is the value of the nth term. So if it's the 7th term, then how much is that 7th term? And this first example, this is what we're solving for. It's simply substitution into this one. And n represents which term it is in the sequence. So these guys are not going to be necessarily the same. So this could be the 3rd term in the sequence, and the 3rd term in that sequence may be 21 or something. Okay? So let's do an example of this one right here, finding the nth term. So I'll give you a sequence. Okay. So in this example here, let's take a look at this sequence. And T48 means find the 48th term. So if this sequence went forever, what would the 48th term be? Well, let's just look at what's given. I've got the first term is 18. The common difference is always going to be like the 2nd term subtract the 1st, or the 3rd subtract the 2nd. Doesn't matter which way I do. 23 minus 18 gives me my common difference, which is 5. Okay, and n, which term do I want to figure out? I want to figure out the 48th term. So these right here are 18, 48, and 5 are what I substitute into this formula. So I say, okay, well, the 48th term is going to be the first term plus n minus 1, 48 minus 1, times the common difference of 5. So the 48th term is 18 plus 47 times 5. And I think I worked that out on the calculator, and I get 253. Okay, and what this is similar to is this is similar to linear patterns and writing the equation of a line given 2 points. It's extremely similar. If the common difference is 5, that's kind of like the gradient of a line, and we can look at these as coordinates almost. First term is 18, second term is 23, and the 48th term is 253. Okay, so arithmetic sequences are like linear patterns. They're going to go up or down by the same amount each time. So in this example, I'm saying, okay, 3rd term is 24, the 8th term is 9. Obviously the common difference is negative because it's going down. Find the first term, the common difference, and the 19th term. So, okay, first up, let's just write our general formula for arithmetic sequence, so finding the nth term. The nth term is a plus n minus 1 times d. Okay? And, alright. Now what I'm going to do is I'm going to look at this one first, and 24 is the value of that 3rd term. And I'm just going to plug in what I have here and say, okay, well, 24 is what that 3rd term is. I don't know what the first term is yet. N is 3, and I don't know what D is yet. I don't know what that is yet. Okay, and this simplifies to 24 equals A plus 3 minus 1 is 2, and 2 times D is 2D. Okay, alright. Okay, next up I'm going to look at this one, and I'm going to substitute what I know into my general formula here. The value of that term is 9. I still don't know what the first term is yet. N is 8. 8 minus 1. And I don't know my common difference yet. That's times D. and that simplifies to 9 equals a plus 7d. Okay, now right here, I should maybe recognize that I've got two equations with two variables. And I'm going to use simultaneous equations to solve. Solve these with simultaneous equations. So what I mean is, okay, if I subtract these two equations, I'm going to cancel that a out. If I subtract these two equations, boom, that a is going to cancel out. 2d minus 7d is negative 5d, and 24 minus 9 is 15. So I'm about to solve for the common difference. The common difference is 15 divided by negative 5. That common difference is negative 3. So that means it's going down by negative 3. Okay, now if we remember how to solve simultaneous equations, once I get the value of that variable, I can substitute that into either equation to solve for that first term. Doesn't matter, take any one. So I can say 9 equals a plus 7 times the value of d, negative 3. Okay, wait. So 9 equals a, 7 times negative 3 is negative 21. So I'm just going to write minus 21. So a equals, add 21 to the other side. Oh, a equals 30. Great. Is a the same thing as t1? Yes, it is. Same thing. All right. Now, what's next? Well, I've got the common difference. I've got the first term, and I want to find the 19th term. Well, I've got everything I need to substitute it back into my equation. So the 19th term means that it's going to be the first term, 30, plus 19 minus 1 times the common difference of negative 3. Thirty plus 18 times negative 3. What does that give me? And I get a value of that 19th term would be in the negatives, negative 24. Okay, so that's one way of tying in the common difference, first term, nth term, which is the 19th term. Nth term just means whichever term you're trying to figure out. And it's a pretty good problem. Let's look at one more. Okay, so in this last one, I'm not asking to find the value of the nth term. I'm saying, how many terms will it take it to get to 437 in this sequence? Not what is the value of that term. The value is 437, but which term is this? Okay, and which term it is n. Okay, you go, all right, well, let's just start with what we know. My first term, 17. Common difference, 23 minus 17 is 6. Okay. What else do I know? Oh, I know. The value of the nth term is 437. And I want to find out what that n is. Okay? Well, let's look at our formula. That's our formula. We're going to substitute what we know. We know this. That's 437. We know my first term is 17. I don't know n minus 1 yet. Or n, I mean. And we know 6. And from here, all this is an equation to solve for n. That's it. You go, okay, wait. If I want to solve for n, then I might want to take that 6 and expand it through that bracket. So I get 6n minus 6. And I just expanded that 6 through there in one step. Okay, and then I might want to figure out, I can bring these together. 17 minus 6 is 11, I think. Yes. And that's a pretty simple equation to solve, because then I just subtract 11 and get 426 equals 6n. And then I just divide by 6, and I'll get which term it is. 426 divided by 6 gives me 71. Okay, so that means I do like to think of this kind of as a linear pattern. Term 1 is 17, second term is 23, dot, 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 and if I got to the 71 term, that would give me 437. Okay, that's how we have to look at these. Alright, what do you think? Doable?